Welcome to a new In the Mail, the series that will touch both your passion for electronics and your bank account at the same time. We're going to start with some connectors. These are somewhat special because they are waterproof, dust-proof, automotive style connectors. I have 15 pieces in this set. There are 2, 3 and 4 pin connectors and 5 pieces of each set. And you can clearly see why these are waterproof, because they have this yellow silicone ring on the plug. So this will prevent water getting into the plug through that point. But you also get these smaller silicone plugs that go with each individual pin, preventing water ingress from the cable side. These are 1.5 millimeter pins and they are rated for 300 volts and 12 amps. And the waterproof class on these connectors is IP68, which means they should be fine underwater, at least 1 meter under. Now, since these are not some brand name connectors, I wouldn't exactly trust them underwater, but I think they will do fine for the occasional splash of water or rain. As usual, there will be a link in the description so you can easily find this product. And don't forget to subscribe to the channel and hit the small bell icon to be notified when a new video is uploaded. The sponsor of this video is jlcpcb.com, a professional PCB factory which currently has the best offer on the market. You can order 10 PCBs for just $2, so check out their website linked in the description below, because it will probably cost you more to do the PCBs at home. Next up, also a set of connectors. These are 2.8 millimeter 2-pin mating connectors. And I think they can also be considered automotive style because they have this locking pin which prevents them from detaching under vibrations. See, they lock in like that, so this connector will not detach under vibrations. These don't exactly have any water or dust protection except for the shell of the connector, but they should be fine for interior wiring like inside the cabin. I really need to get myself a crimping tool for this style of pins. So this is how these pins look like. So if you know what type of crimping tool I need for these types of pins, and you know of a good and cheap crimping tool, please leave a suggestion in the comments below. Next, I got myself one of these new fancy USB meters from RuiDeng because I've been using this simple one for years and it's been fine, but there are these new ones with higher resolution and increased functionality which should improve the testing of USB power devices here on the bench by providing higher resolution and accuracy. It comes in this nice metal box. So this is the UM25C model, which is the higher resolution and accuracy model, and the C denotes it has Bluetooth communication. This particular model has 1 millivolt and 100 microamps resolution. You can also get the UM25 model without Bluetooth, and the price will vary slightly, but I think it's worth paying a bit extra in getting the Bluetooth module because that adds some functionality. There is also a UM24 model with lower resolution, and obviously that costs less. And they have an Android app that you can use to visualize the data, and also a PC app, so it's a pretty versatile USB meter in terms of apps and data logging. This model can measure up to 5 amps and 24 volts, so it's compatible with the quick charge technology, and I think it can also identify that and show it on screen. This USB meter is constructed like a sandwich of PCBs with a couple of acrylic layers on the outside, It has three types of input. It has a Type C USB input, a micro USB input, and this classical Type A USB input. And on the output, you also get a Type C output and this classical socket for plugging in various devices. So let me show you how it looks when it's powered on. Oh, they even have an animation on startup. So let's plug in something that so you can see that high resolution that it has. I'm not sure if the least significant digits are all that usable. I'll have to see that while using this. So let's try to switch through the different menus, because I have two switches on here and two on here, and it looks like I have different menus. Okay, so these ones on top are for rotating the screen. I don't want to do that. I just want to scroll through the menus. Yep, so here it shows you the data lines. That's really cool because it measures the voltage on the data lines and tries to identify the mode your device is in. And it even shows you a graph of voltage and current. So that is pretty cool. This LCD is 1.44 inch wide, and I like the looks of it. I can't say it's the best user interface I've seen. These Chinese products seem to love to use all the colors available in their user interfaces, but nonetheless it's functional, and I think it will do a good job. Next up, a pretty simple item, a cheap 24 volt relay, which looks like it got a bit of a shave during shipping. It has an interesting story behind it. A few weeks ago I found this PIR motion activated light in a storage room, so I wanted to install it. However, I quickly discovered it wasn't activating. Upon a closer inspection, the relay was dead, and in my bag of relays I only had 5 volts and 12 volts relays, or maybe I had a 24 volts one but was not this size and I couldn't fit it on the PCB. So I ordered this one from eBay just to fix that lab. I know it's not a good quality relay, so I wouldn't expect much in terms of reliability, but it just wasn't worth investing more in that old lamp. Paying for a good relay plus shipping would come close to the cost of a new PIR lamp, so it just doesn't make sense to buy a high quality relay for that lamp. A while ago a viewer suggested I try the paste flux from Mechanic because it works well. I have used solder paste from Mechanic in the past, and yes, it has worked well for me. And when a viewer suggested I should try this solid paste flux from them, I said, well, I'm gonna try and see how it works. The recommendation is that it has a certain viscosity that could help with soldering SMD components by keeping them stuck to the PCB while you tack the sides with solder. So I ordered a can of this paste flux. You can find them in various sizes. I believe this one is the 50 gram can, because it's UV50 part number, so I think that's what it means. So let's give this one a quick try. I'm going to change the camera angle here. So I think you can use a toothpick to apply this paste. You can see it's kind of in a gel form. So let's try to take a bit of this paste. Yeah, it does have some tackiness, but I'm not sure how that's going to behave once I start applying the heat. Okay, so I have some of the paste applied to those pads of R11. Now let's try to solder that resistor and see how it behaves. First, I'm gonna place the resistor on top of the paste. Yeah, and it really you can really feel how it grabs the resistor because of the tackiness of the paste. But let's see if that holds while I apply heat and solder. So I'm gonna try one end with first applying solder on the tip of the soldering iron. You see the tension of the surface tension of the solder just pulls the resistor with your soldering iron. So you still need a second hand to hold the part with your tweezers. So I don't think there is any real advantage to this type of flux. It's just a matter of preference. It works as a flux. I was able to solder that nicely. I saw it melt, but I don't think it has any real advantage over normal liquid or gel flux. Sure, liquid flux flows everywhere on your board once you put it on a pad. Gel flux or paste flux, I think it's basically the same thing. The chip will not stay in place once you apply solder because the surface tension on the soldering iron tip will make it stick. So as you saw in the test, it works as a flux, but it doesn't do any wonders. It's just a solid paste flux. If your preference is to work with this kind of stuff, yeah, I can recommend getting a can because it really works. It's not one of those bad fluxes that you get from China for cheap. This is working okay. Next, I have a set of 100 pieces surface mount LEDs in orange. These are 3528 surface mount package according to the product description. 600 nanometers wavelength with a 2 volts to 2.4 volts forward voltage and 20 milliamps forward current. Orange LEDs are not as common as the other colors, and good ones cost a fair bit. That's why I got these ones from AliExpress. They were way cheaper for this pack of 100, but I think I'm gonna get what I paid for. I'm expecting these to degrade over time, and I'm not sure about the color either. Let's just take one out and test, see how it looks. Maybe it will look good on camera. So this is the kind of color I'm getting. It looks more in the red wavelength than in the orange one. At 2 volts the LED is pulling 20 milliamps, but the brightness is not that great. It's like the brightness coming off I don't know, an 0603 normal LED, nothing fancy, and the color is not exactly orange. It's more like a pale red color. I'm not sure how that shows up on camera, but yeah, I'm seeing it very close to the color of the solder mask on this PCB, which is red, so not very orange like I needed to. And that's the thing with these cheap LEDs from China. They're nice and cheap for one-off projects, hobby things, but yeah, if you're really looking for a specific LED with some specs, yeah, don't just go buy them off AliExpress, because they will first of all, you will not get the proper data sheet for that part, and second, the quality will be much lower than going with a brand name manufacturer of LEDs and getting them from a known distributor. If you remember my videos about adding AutoBed leveling to my Creality CR10 3D printer, you know that didn't go that well. I had a few issues there, so I ended up removing the capacitive sensor from my printer. But I continued searching for a better option, so I bought this touch sensor, which originally is called BLtouch, but mine is just called Touch. It's obviously a copy of the original, but I think it should work. or better yet, I hope it will work. So this sensor uses a Hall effect sensor to detect when this pin is moving, and this pin will be moving when it touches the printing bed. In terms of connections, you have a few extra wires. You have to connect a set of wires to the stock Z-end switch, but you also have to connect a set of wires to an extra pin, which as far as I know is not available on the CR10 motherboard, so you have to sacrifice the onboard buzzer to connect the control signal for this sensor, which has to be a PWM pin, because this sensor has a coil inside and it needs to be energized. So the PWM pin will probably drive that coil from the Marlin firmware. I'll probably do a separate video of that in the future, showing how I install this on my CR10 and the results I got with this sensor. Until then, if you'd like to order one, I will place a link in the description below. My next item is a roll of Teflon adhesive tape. This is 10 meters long and 10 millimeters wide. And there are two main properties for this type of tape. One is the high temperature. It should resist up to 260 degrees Celsius. And the other one is the non-stick property. Like having all kinds of electronic components in the lab, I also like to have different types of adhesive tapes. This one is particularly useful for a bag sealing machine, because there you have a hot nichrome wire or a similar material, but you can't apply that directly to the bag you are sealing because it will just melt and stick to the bag. So you cover the hot part with this type of tape, and you still transfer the heat to the sealing joint, but the PTFE material on the tape prevents it from sticking. I'm sure there are other high temperature applications for this kind of tape, so I think it's useful to have something like this in the lab. This is a UV LED nail lamp I came across eBay during a search for UV LEDs, and I thought this could be interesting to take a closer look at. I'm not sure if mine is pink like in the image, but we'll find out soon as I take it out of the box. So indeed it appears to be a pink enclosure. And it has these folding stands on each side. We can also see the LEDs. There are 6 of them. And here's something interesting. Not sure if this is visible on camera, but I can see it with my bare eye. Inside each of the LEDs I can see 2 dies, one on the left and one on the right. There is no lens other than the soft material on the top of the LED. But having 6 of them, I think gives a pretty good coverage at this height, because I think this is intended to stay like this, and you just put your nails under the lamp. I've read the product description on this, and I think it has 2 modes, a 45-second mode and a 60-second mode, and it must have an internal timer, and it will stay on whichever preset you have selected. And I think that's what's required for hardening the nail paint or gel. Now, of course, I'm not going to start painting my nails, but I was curious to see if this could maybe be repurposed to expose PCBs, for example. It's true I haven't done DIY PCBs for a while, since they are so cheap to order from China these days, and you can get relatively fast DHL shipping for a few bucks extra. But still, for those of you looking for a cheap and small exposure unit, I think this could do the job. There is the issue of wavelength. In the user manual I found a line which says 365 plus 405 nanometers. So I'm left wondering if the 2 dies I'm seeing inside each chip are responsible for the 2 wavelengths. Maybe yes. Anyway, for exposing the photoresist found on PCBs, you usually need in the range of 350 to 400 nanometers, so this little gadget should cover that nicely. In terms of output power, I think the product page said 5 or 6 watts, but we'll see that I don't think this thing can output 6 watts. Let's plug it into the USB meter and see at least how much power goes in. How do we turn it on? With this button. Yeah, so about 3.7 watts of power going in. Definitely we're not going to be having 5 or 6 watts going out, because we're not creating energy out of thin air. So at most it will be 3 watts going out of this, but of course these LEDs are not that efficient, so it will be much less than that. But I can see it gets some pretty good coverage on the bench. I'm not sure if there are any hot spots or not, but to the naked eye it looks to provide good coverage in there. So yeah, I think this might be worth purchasing if you plan to expose some PCBs at home. You can definitely work with the distance and maybe increase or decrease the distance and see what kind of results you get. You are limited to maybe this size, which is a square of, I don't know, maybe 10 centimeters by 5 or 6 centimeters. But anyway, at home, I don't think you're going to be making PCBs larger than that. So yeah, I think I'm gonna keep this one around just in case I need to expose any DIY PCBs in the future. And our last item in today's video is this lithium battery all-in-one circuit. It's pretty small and it can charge the battery, it boosts the output to 5 volts, it has a level indicator via LEDs, and it also provides overcurrent and overvoltage protection for the battery. It's basically what you need if you decide to add lithium battery to any circuit. You want something to charge the battery, you probably want to boost the output to 5 volts, and you want some protection for the battery. It doesn't say anything about over discharge protection for the battery, but I would imagine they have this feature because it's quite basic in terms of battery protection. You don't really have battery protection if you don't have over discharge protection. So we can put that to a test using a bench power supply, and I'm going to lower the voltage to see if that protection kicks in. So I did a quick test, and if I drop the battery voltage to 2.8 volts, it will automatically shut down and it won't turn back on until the voltage is at least 3.3, 3.4 volts. So yeah, I think it has that over discharge protection, and I think it's the threshold is around 2.8 volts. This is a single chip solution handling all of this, but unfortunately the numbers are wrapped off the chip, so I can't give you any info on that. In terms of output current, it can do 2.1 amps and the circuit will automatically turn on if the load is at least 50 milliamps. If the load is less than 50 milliamps, the circuit will automatically turn off after 30 seconds, and it doesn't turn on itself. You have to, there is a key signal right here, and if you pull that low, it will turn on, but if the load is under 50 milliamps, it will automatically turn off after 30 seconds. So this sounds very similar to many power banks I've seen, so it might be a chip designed specifically for power banks and used in a lot of them, because I have seen similar behavior. Having all of this functionality integrated in a single chip will lower the cost a lot, allowing them to sell these cheap power banks. Of course, it has its limitations with just 2.4 amps of output and a limited charge current. They say it can do 2.4 amps charge current, but I doubt it can do that without overheating. Nonetheless, I think this can be used for small projects that need a small lithium battery. That was all for today. Thank you for watching this in the mail video, and I hope you found something interesting to order today. Remember that by using the links I place in the description of the video to purchase something, I get a small commission which adds up to the end of the month and keeps these videos coming. If you are new to the channel, don't forget to subscribe and hit the little bell icon to be notified when a new video is uploaded. See you next week.